While Earth is afflicted by climate change, it's from space that we can look at solutions for the sustainable future of our planet. As part of the environmental program Copernicus, developed by the European Space Agency, Sentinels are a whole family of satellites revolutionizing Earth observation.
So these are the only environmental monitoring satellites which will operate for a guaranteed period of several decades. We already have 4 missions of each class guaranteed for launch over the coming years. And so we'll have from those almost 20 years worth of data, and we're already preparing the follow-on to that. As a result of that, we can guarantee that we can have these data sets available for a very long period, consistent data sets calibrated against each other. Not just technically is that very important, but also politically. One can begin to develop policies and adapt strategies for the way we manage our environment in future, safe in the knowledge that we're going to have continued access to these information to manage those policies.
The Copernicus satellites monitor land, oceans, ice and atmosphere, providing us with very accurate and easily accessible data.
All those developing countries for which this information is so critical have equal access to the data in the same way that those who funded the program. And of course this is very important for them for areas of food security, for water management, for forestry and deforestation. There's been increased speculation on food stock prices, on grain prices and other types of foodstuffs. And a better information system worldwide would allow that volatility in prices, which works very much against the poorest, to be minimized. And so we have been working on a project called GeoGlam, which helps to provide better information about the status of the world's food stocks and growing, in particular to crops which are currently growing, to predict their yields early in the growing season, so that those ups and downs we see, the volatility of food prices which are based on that, are removed, and so we have a more stable price which is suitable for all.
The latest of the Copernicus satellites, Sentinel-3A, was launched in February from Russia. This satellite will remain in space for 7 years to collect near real-time measurements like the diminishing sea ice in the Arctic, land and sea color, sea levels change and seawater quality. Combined, this information will support ocean forecasting systems, maritime safety and global land services. Developed in the UK, one of the main instruments of Sentinel-3A is deployed for its primary task of investigating our oceans.
The world's oceans are a big source of heat, and that heat drives our climate and it drives our weather and has a big influence on how we live and how we do things. The sea and land surface temperature radiometer is designed to, as its name suggests, to measure sea and land surface temperatures. And we do that by measuring a part of the electromagnetic spectrum that we can't see with our eyes, but we can feel, and that is the infrared. It detects the infrared radiation from space at 800 kilometers above the surface of the Earth, and it measures those temperatures to an accuracy of 0.1 degrees centigrade. The first images were over the Canary Islands, and we can see some quite clear, sharp features. We can see the islands, we can see vegetation on the islands, we can see some very interesting cloud features, particularly around Madeira, and we can see a very large crack which is running from the Antarctic Peninsula right down south, and it's quite a stunning image, and it's just showing the power of this kind of instrument.
Here, in the Royal New Space Test Facility, engineers are calibrating the sophisticated heat sources for the mission of Sentinel-3B, launching next year.
In this tank here, we have the blackbody sources for the Sentinel-3B instrument for SLSTA. And what we are doing is we have to test that the blackbodies will work in a space environment, which is why they're vacuum. Without these calibration sources, the instrument is basically measuring something, and we need some way of converting that raw detector voltage into a physical quantity like temperature.
Meanwhile, just next door, a private company is creating technological platforms to facilitate the access to the exploitation of the Copernicus free images for practical applications.
One of the most significant things that we've been doing across a number of projects is working with technologies that allow us to do that. So, for example, having Earth observation embedded as a layer of information within a web application that any user can access and interact with.
We're using 3D games engines with Copernicus data to really help visualize and create intuitive applications for the end user. An example of this, for example, is our space-enabled environmental platform. So for this particular platform, we're looking at mining and what impact that has on the environment, and actually what has changed over a period of time.
We are also working with the farming community to look at ways in which we can use satellite imagery to more efficiently monitor the way in which a crop is growing. It's not so obvious how a country who's not familiar with working within the space sector would access that kind of data. We've been working very closely with the government in Chile to look at ways in which we can improve their access to the data, but also to help educate them in terms of how they use the data. Now, the data from Sentinel satellites will be extremely useful for providing baseline mapping of the environment, for example, understanding where all of your infrastructure is versus where your agricultural land is, and therefore being able to plan accordingly.